Okay, hello everybody, and welcome to my presentation for my final project in our robotics class. My final project is called Heat Sensing Robot. And yeah, today I'm just relaxing a little bit. It's my birthday, so I might look a little chill, but everything's okay. Anyway, so Heat Sensing Robot. So when I started this project, I had a clear idea in my head about what I wanted to do. And that was I wanted to make a robot that could sense heat and react to it. I had a temperature sensor and I had an Adreno, and I thought to myself, hey, I can do something cool with this. So that's what I did. Uh, and what I really wanted to do is make a robot that could sense heat and react to it, like I just said. But I also wanted to do something out of the norm. So my first thought was make a robot that could fight fires, right? I mean, everybody would think that's cool, but that's been done like a million times, right? So, all right, let's see what else we got. Then I thought about making a robot that would be able to chase a heat signature. You kind of, like you'd have a lighter and then it would follow it around. But then I realized that this has also been done. I mean, just take a look at heat-seeking missiles. So, I was kind of like, yeah, that's cool, but nah. So I decided to go in a different direction. And I decided to make a robot that would run away from heat signatures to preserve its existence. So, in other words, I wanted to give the robot a sense of artificial intelligence or life, a pseudo-type life, that would say, hey, it's hot here, I better move before I get burned, right? So that's what I decided to do. Okay, so at first I decided to build this quadruped robot. A quadruped robot is a robot with four legs. It kind of resembles a spider. The reason why is I like the idea of having a robot that could articulate. I felt that it would have some advantages over certain other robot types. So I searched a lot of designs on the internet, and believe me, I went far, far into this. And then I found a few that I liked, and I decided to combine the best features of them all into one robot. And I made a 3D prototype, and that is this 3D prototype right here. So, as you can see, it's a spider-looking robot, all right. And these wires here are what connects the servo, so it looks a little messy. But the cool thing about it is he glows in the dark. But on to my next part. I printed up the, as you can see, I printed up the spider or the quadruped, and I mounted the 12 servos that I needed to get it to work. But at that time, I realized, boy, I made a really bad error. See, I was using an Adreno Uno, and the Adreno Uno is a very mighty platform. You can do a lot with it, but you can't make a heat-sensing spider with it because there just wasn't enough pins. I was missing one pin. Can you believe that? One. And it screwed up my whole entire project. Yes, it did. Well, so it wasn't going to work properly. Okay. Well, there were some more issues with that. It wasn't a very good thing for it to happen to me, right? It wasn't very good because I was also pressed for time because at the time I thought I was going to be moving into a new residence, which I didn't, by the way. And Professor Perry, if you're watching me, I'm not sure if you know St. Clair Shores, but there were these really nice apartments in St. Clair Shores. They're lofts, they have fireplace, they're beautiful. They wanted like $1,800 a month to move in there. Well, with my new job that I got from graduating college with you guys, I could afford it. But when I walked in there, there's no way I'm paying $1,800 for that place. So I'm just going to stay where I'm at, save my money, and buy a house. But anyway, moving on. So that kind of left me with only one option, and that was to rethink my idea and produce something that would work with the materials that I had. So I had to start searching for answers, and I went back to the internet. And eureka, I found something. I found a cost-effective wheel robot chassis on Amazon that would work nicely. As a matter of fact, it's kind of the same one that we kind of were using in the Robot 172 class. I think it was 172. Anyway, it worked great. You know, I bought it, and it actually came with a couple of cool things. It came with the motors. It came with the wheels. It even came with some interrupts on it, so you can, you know, do some interrupts. I didn't use the interrupts for this project, though. But anyway, this would allow me to complete my project. But I had to do some modifications. However, I knew my goal was finally in sight. So, having the right materials for the job, I got to work. I used the Arduino as my embedded platform, and this time it would have everything I needed. You know, they're really good for getting started in the embedded world, you know. And believe me, it's what launched my career. Okay, but there were a couple of caveats that I had to deal with. Well, how am I going to power these DC motors, right? I can turn them on and turn them off, and but how am I going to get it to go in reverse, forward, stop, go left, go right? Well, the answer is called an H-bridge. And what the H-bridge does is it's a motor driver that will do exactly what I just said it will do. Make it go forward, backward, reverse. I'm sorry, forward, reverse, left, and right, you know, and stop. And then I had to hook up the temperature sensor, which that was pretty easy to do. There was one more task before my creation was complete, and that was I had to rewrite the code to compensate for the changes. So yes, instead of controlling, you know, 12 servo motors, 3 on each leg to articulate, all I needed to do now was interface with an H-bridge, which made it really easy. If you know how to wire up an H-bridge, which is another lecture for a different time. Anyway, the Arduino code was easy because Arduino makes it easy. They have libraries for this stuff. I do want to go ahead and maybe boost it up a little bit and do it in C++ later on with, you know, maybe Microchip Studio. Yeah, I do have some other microchips on the way. So I'm thinking about using an ARM chip. And actually doing the spider robot, you know, after this, obviously. But anyway, moving on. So yes, it worked, and I have a robot, and I'm going to show it to you in a minute. But well, here it is, kind of. I know it's messy and everything, but it's a proof of concept, and it's a prototype. So you have to, hopefully, you'll give me a little bit of leeway with that. Up next, I'm going to give you a demonstration video of the robot in action. So stay tuned. Don't turn this off. We got a little bit more to go. All right, I'll talk to you in a little bit. Hey everybody. Okay, so this is my cowardly little robot here. And what he's designed to do is he's designed to run away from fire. Yes, he does not like heat. So, yeah, so originally, I know you've probably seen my previous video. I was working on a quadruped robot that was going to do the same thing, but unfortunately, the Arduino didn't have enough pins in order for me to be able to execute it right. So, this is just a proof of concept, so I apologize for the messiness, but it does work. So here's what we got here. Let me walk you through this. We're using the Arduino Uno as our embedded platform. The 328P is going to be just fine for what we need to do. Okay. I had to rethink this a little bit. Instead of using servo motors, I'm using DC motors, 2 of them, that are driven by this H-bridge right here. Now this H-bridge is a little component that's going to tell the robot to go forward, backwards, turn right, and turn left. The disadvantage with these motors is this. You need a higher voltage source than 5 volts than the Arduino can put out, so you have to run a separate voltage source. I've got a 9-volt voltage source right here. I also have this DHT11, I believe it is, and that's the sensor that's going to sense temperature right now. So how it's going to work is, well, basically I'm going to heat up the sensor until it reaches a certain degree, and then the robot's going to take action. But he's just going to do a little bit more than that. He's actually going to talk to us. So if you see here, we have, that's the program. That's all the code right there. And if in the background you hear some noise, I apologize. That's my noisy, obnoxious bird who always likes to make noise when I'm trying to do an assignment.
But anyway, moving on. So right now, our little cowardly robot's saying, hey, it's all clear. There's no fire detected. The stop mode is activated. Once it reaches a temperature of 85 degrees, however, that's going to change. He's going to get scared. What he's going to do is he's going to try to maneuver out of the way. So he's going to turn and then go in the opposite direction. It's quite simple, really. You know, I mean, but for what it is, I like it. So the one thing, though, that I'm going to tell you is when he starts to move, I'm actually going to pick him up because I have him tethered right now, so you can see basically you can see the serial monitor going on, and unfortunately he likes to get tangled up in a web here. So I am going to try to do this in a way where it is not going to be hard. Now, it's going to be kind of hard because I have this heater right here. Yeah, and once I heat this up, you'll see that he's going to say, hey, hold on a second here. So it's gradually going to heat up. I don't want it to go too much. Okay, so we're at 82. We need to get it to 85. That should do it. Oh boy, there he goes. Oops. Oh, one of his wires came down. Okay, so he did. He went forward, and then he said that he checked again, and that there was more danger, so he was moving forward again. Then he's seen that he was out of the danger area, so he's cooling down, which is he's going to wait for everything to cool down for 10 seconds. Now the thing is, one of these motors might be, yeah, it is. One of the motors is off right now because it just, the wires just moved. I don't have them soldered together. So let's give me a moment while I make the necessary repair, and I'll show you again. All right, give me one moment. Okay, yeah, we're connected. So now you can see he's moving out of the way. He said that, you know, he was going forward to get out of the way of danger. So he's registering it as 98 degrees still. He's going to wait like 10 seconds. And he's going to try it again. Again, I apologize for this wiring mess, but yeah, I was running out of time here. So, well, let's see here. We'll give it about 10 seconds to see what he says. Might be a little bit more. I got a feeling he's still going to be like chickened out and move because this isn't going to cool down in time, I don't think. But at least it'll give us some stuff to do. I might want to adjust the timer on this because it is kind of long. Here. What did I put play? Oh, I did a whole minute. That's why. Oh! Well, he says it's all clear right now. Oh, nope. He says it fired. Turn. He's turning out of the way. All right. Going forward now. Pretty cool, huh? Anyway, guys, that's my robot. Talk to you later. Bye-bye.